Hi guys, so today we're going to take a look at question 3 of paper 2 of the 2016 exam. Okay, so we want to show that cosine of 7a plus cosine of a over sine of 7a minus 7 of a, minus sine of a is equal to cotan of 3a. Okay, so the first thing we want to take a look at is, well, what is cotan of 3a? Okay, so cotan of an angle is defined as cosine of the angle all over sine of the angle. So it's basically the opposite of the tan function, which is, so tan is the opposite, it's sine over cosine. And that's why it's called, cotan of a. Okay, so cotan of 3a, so cotan of 3a, what we're looking for, would be cosine of 3a over sine of 3a. Okay, so this is sort of a daunting looking question. It doesn't really look like the top or bottom look anything like how we would want them to. But, we're just going to take this bit by bit. We'll focus on the numerator first, try and see if we can simplify that at all, and then do the same with the denominator. So first things first, the numerator, let's consider cosine of 7a plus cosine of a. Okay, so we've got the sum of two cosines, cosine of one angle plus the cosine of another angle. And so if we go to our log tables, we actually have a formula for this. So if we've got the sum of two cosines, we know that cosine of a plus cosine of b is equal to 2 cosine of a plus b over 2 times cosine of a minus b over 2. Okay, so in this case, our first angle is 7a. So cosine 7a plus cosine of a. So using our formula, this would be 2 cosine 7a plus a over 2 times cosine of 7a minus a over 2. Okay, so we're making some progress here. And so if we just simplify this, this is just 2 cosine 7a plus a is 8a over 2 is 4a, and then cosine of 7a minus a, 6a over 2 is 3a. Okay, so we've simplified the numerator somewhat. So we're going to do the same with the denominator. So let's consider sine of 7a minus sine of a. Okay, so again, we've got this weird expression where we have the difference now of two sines. And we actually have, again, we have a formula for this. Sine of a minus sine of b, so sine of one angle minus sine of a different angle, is equal to 2 cosine a plus b over 2 times sine of a minus b over 2. Okay, so now if we use this formula for our expression sine of 7a minus sine of a, we can rewrite this as 2 cosine 7a plus a over 2 times sine of 7a minus a over 2. 7a minus a over 2. And then this will just simplify to 2 cosine 4a sine 6a over 2, 3a. Okay, so we have the numerator and our denominator. We've rewritten those. Okay, and so now we've rewritten those. So let's go back to the start, and we have cosine. Let's rewrite out this fraction. Cosine of 7a plus cosine of a all over sine of 7a minus sine of a is equal to 2 cosine 4a cosine 3a, the numerator, over the denominator, 2 cosine 4a sine 3a. And now we see that the 2's will cancel, the cosine 4a will cancel, and we're left with cosine of 3a over sine of 3a, which, as we outlined earlier, was exactly what we wanted to show. We wanted to show that our fraction was cosine of 3 over sine of 3a, because that equals cotan of 3a. That's the definition of cotan of 3a. So this is cotan of 3a. And we have our proof. And now this is one of those questions that looks very daunting, but we just worked through it bit by bit. None of it was too difficult. None of these steps were, massive leaps in logic. And then the next thing you know, we're at something that looks like the answer, and then you're at the answer. Now on to part B. Given that cosine of 2 theta is 1 over 9, find cosine of theta in the form plus minus square root a over b, where a and b are natural numbers. Okay, so they've given us that cosine of 2 theta is equal to 1/9, and we want to find cosine of theta. So this is a little bit of a tricky one. It's hard to know where to start here. Well, we'd like to, given cosine of 2 theta, how could we find cosine of theta? Well, we could actually just solve for theta, but that doesn't seem like the right way of going about it, and it would probably give us this weird decimal in the calculator, and we wouldn't be able to write it in the form square root a over b as they've asked us to. So we're just going to go with the trusty log tables and see if we have any formulas to help us. And so if we go to the log tables, we'll see we have a formula for cosine of 2a, and it's just cosine squared of a, so cosine a squared, minus sine squared of a. And now we know that this whole thing, so now if we rewrite this, if we rewrite our cosine 2 theta using this formula, we get cosine squared theta minus sine squared theta, and we know that this equals 1/9. Okay, but this doesn't really help us. So we have a cosine theta term here, but we also have a sine theta term, and well, we don't really know what to do with this term. So we'd like to get rid of it and only have a cosine theta term. So is there a way that we can relate sine of theta to cosine of theta? Well, again, if we go to the log tables, we see that cosine squared of an angle plus sine squared of that angle is just equal to 1. And, well, this comes from the sort of the unit circle definitions of sine and cosine. So if we have our unit circle, and let's say we have some line here so that, you know, this is our angle, then cosine represents this length here, this x here, the x coordinate, and sine represents the y coordinate. And because this is a right angle triangle and the unit circle has radius 1, we know that x squared, cosine of the angle, plus y squared, sine of the angle, is equal to the hypotenuse, which is 1. So that's where this formula comes from. So now we can use this formula to rewrite sine squared of theta in terms of cosine squared of theta, or just in terms of cosine of theta. So we get 1 minus cosine squared of theta. So then if we sub that back into our formula, cosine 2 of theta equals cosine squared of theta minus 1 minus cosine squared of theta equals 1 over 9. Okay, so now if we gather these terms, we get 2 cosine squared of theta. We bring over the minus 1, and we get 1 plus 1 over 9, so 10 over 9. And then cosine squared of theta is 5 over 9. So we have cosine squared of theta, and we're looking for cosine of theta. So, well, we're just going to take the square root of both sides, and we get that cosine of theta equals plus minus, because it's a square root, the square root of 5 over 9. Okay, and so if we know what we know about square roots is that square root of a over b is equal to, so let's just write that out. Square root of a over b is equal to the square root of a over the square root of b. So this equals the square root of 5 over the square root of 9, well, plus minus, which is just plus minus the square root of 5 over 3. And we have cosine of theta in the form that they've asked us for.